Okay, so we are going to be graphing a bar graph and a line graph today. So you're going to be learning the difference between a bar graph and a line graph and when to use which. So the main thing that you need to understand is a bar graph compares amounts. Now, when we say amounts, this is qualitative data, okay? So you've already learned that in your paper packet that you did with LTF. We learned that bar graphs is categorical. You put spaces in between them, and there are words or numbers that are not counting at the base. So that is qualitative. Or categorical. Line graphs show how it says to use to show the change of one piece of information as it relates to another change. Generally, these are quantitative, okay? Now, what's important to know is that the x-axis is the horizontal axis, and the vertical or the y-axis is the one that goes up and down. All of your graphs need a title on all axes, so on both the X and Y, and a graph title. So you will have 3 titles. Then you need to determine what your independent variable is. Remember, the independent variable is what is being tested. So it's being controlled. It would be such as like times or dates, depth, temperature, and it's placed on the x-axis because remember we have dry, mix. So that mix is your manipulated independent on the x-axis. So it's going on the x-axis. Your dependent variable is what is being affected by the independent variable. It's the result of what happened, and it is placed on the y-axis, and that is from dry. Dependent responding, remember it's responding to the independent on the y-axis, and it is what is being changed. Or measured. So you are measuring, you're getting a measurement value from your dependent variable. Now, the scale of each variable is very important. So remember, we've talked about this throughout our graphing data, but you need to make sure that you understand what goes on the y-axis and how the scale goes on the x-axis. Now I want you to pause this and go watch the zombie video that explains the difference between the x and y, the x-axis and y-axis, and when to use a line in a bar graph. So you're going to put your notes from the zombie video here. All right, so welcome back. You should have finished your zombie notes video. We are going to determine now which graph to use based off the information given. And then we're going to determine if we need a where our independent and dependent variables are and what lines they go on or what axis they go on. So this information gives us months and the number of deer. So we're going to say months because that is categorical. Number of deer is quantitative, but our months is categorical. That means we are having a categorical graph, and we know that categorical graphs are bar graphs. So now we need to determine which one is our x-axis and which one's our y-axis. All right, so we know that using dry mix, our independent variable is what is being tested. So, and that's on the x-axis. It's what's being tested or changed or manipulated. So what's changing is our months. So we know that our months is our independent variable, and the number of deer is our dependent variable. So now we're able to put those titles on both of our axes. So the months are on our x-axis because it's the independent, and the number of deer is on our y-axis because it's our dependent variable. Now we also need a title for our overall graph. So a good title that's going to incorporate both of our x-axis and our y-axis. So it could be like number of deer spotted monthly. So we've got both of our titles. We've got our overall title. Now it's time to do our scales. So we know on the bottom down here, we're going to put our months. But it's important to remember that on bar graphs, the bars do not touch. So we're going to start out with January. We're going to skip a bar and then February. Now, keep in mind, it does not go January, February, March, April, May. Now, you could have started with September and went to February. I just wanted to do my months in order. But either way is completely fine. So we're going to go January, February, September, October, November, December. And those are our months. Now we need to graph the number of deer. All right, so we need to determine what our scale is going to be. The highest number is 38. So let's see how many bars we have to see if that 38 is easily divided into even numbers. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I've got 20 bars all the way from the bottom to the top. 20 does not divide easily into 38, but 40 does. So we can do 40 at the top because it's greater than our highest number, and it's easily divided by the 20 hash marks. So we're going to start at 0, and we're going to go up by 2s to get to 40. So we're at 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. It's very important when you're creating graphs to do it in pencil because you don't always know if your scale is going to turn out perfect. You may think that you've counted up correctly and that your scale is going to be great, and then all of a sudden you get to the top and you don't have enough numbers. So you have to completely start over. So it's important to be doing it in pencil just so if you do make a mistake, it's easily fixed. All right, so now let's go and graph our data. So on January, we saw 15. So we don't have a 15 on our graph. We have a 16 and a 14. So we know we're going to have to go in the middle. So I'm going to graph this for January. Then I'm going to do February. So February is at 12. And remember, on bar graphs, the bars do not touch. I'm going to pause the video and graph the rest. I want you to do the same. Remember, do it in pencil just to make sure that you are getting it correct. And then I want you to come back and play the video and see what your results are. Okay, so you should have finished graphing your number of deer per month. All right, so now we're going to go down here and answer these questions. So it says, what is the independent variable? Well, we've already identified that because we had to graph it. So the independent variable are the months. The dependent variable is the number of deer. An appropriate title would be Number of Deer Spotted Monthly. Now, I could also ask you other questions like you would see on your test. I could say, identify what one of the bars mean. So you would choose a bar and you would identify it. So if I asked you, what does identify one of the bars for January, what does it mean? And you would say that there were 15 deer spotted in January. I could also ask you, what does the overall graph tell us? And you would be able to say that September would be the highest spotted month for deer, and it decreases as you get to the colder months. So you can see that September is going to be warmer than October. October is warmer than November. November is warmer than December. December is warmer than January, and January is warmer than February. So deer come out less as the weather gets colder. All right, moving on to the next graph. This was going to be a line graph. So you've done these similar in math. The reason why we know this is a line graph is because we have data that is quantitative, that is increasing in days, and then the number of bacteria is also increasing. So this is a line graph. Now, we need to identify what our independent and dependent variables are so we can graph this. Now, because we have numbers on both of them, it may be a little difficult for you to determine what is being measured. But if we can see, we're not measuring the number of days. We're measuring the number of bacteria. So that is going to be our dependent variable. We are testing or changing the number of days. That is our independent variable. So now we can create our titles. So we're going to copy. We know that our independent variable goes on our x-axis. So we're going to title that as number of days. And on our y-axis, we have our dependent variable, and it's number of bacteria. We're going to create a scale on the bottom and create a scale on the side. I want you to do this by yourself. Pause the video now. Then you'll come back and determine if your scale is correct. Okay, so you should have created your scale. I want you to see if it's the same or near the same as mine. So on mine, my number of days go from 0 to 6 because that's the number of days in our independent variable. Now, I did skip a row, so mine are going up by 1 point, our points. I just did that though, so I would be able to easily graph. If you did 0, 1, 2, 3, 4, 5, 6, that would be perfectly fine. On our y-axis, I went up by tens because we had 20 lines and I had to get all the way to 200. Now, if I would have went up by twos, I would have only got to 40. So if I would have went up by fives, I would have only got to 100. So I had to go up by tens. Now, I'm going to graph the data. I want you to pause this here, and I want you to graph it and connect your line to see if you got it correct. So here are our plots. We see that at 1, we had a number of 4 bacteria. At 2, it was at 16. At 3, it was at 40, and then went to 80, then 100, and then all the way up to 200. So we can see a dramatic increase between days 5 and 6. So going down to the bottom, we're going to answer our questions. Our independent variable we've already determined is the number of days. Our dependent variable is the number of bacteria. Then we determined that the appropriate title was the number of bacteria counted daily. Now, on your test, I could ask you to identify or locate one point and discuss that point. Or I could ask you to discuss the overall graph. So you would say the growth of bacteria slowly increased until you got to day 5, and it dramatically increased between days 5 and 6. So you need to be able to determine a graph and be able to read it as well.